Hello, I'm Dr. Nushin Nasiri. I'm a lecturer at the School of Engineering at Macquarie University. I'm also head of nanotech laboratory here. I do both teaching and research. My research is more focused on nanomaterials and their application in health, energy, and environment. My teaching is more focused on mechanical engineering units, which are I teach about materials, their application, and different manufacturing processes on materials. I've been here at Macquarie for almost 2 years, and I'm enjoying my time being involved in many different activities here, both in the teaching and in the research area.
Brilliant. Hi, and I'm Danish Faiz. I am a product system engineer at Cochlear. I studied at the University of Queensland and I studied mechatronics engineering. I started my professional career about 3 years ago, so I think maybe 7 or 8. I was just in the exact same position as you guys, starting at my engineering university life, and that was a really exciting time, and I guess we'll talk about that more today.
Yeah, and why you chose engineering?
Yeah, so for me, engineering was a passion. When I was growing up, I loved technology. I had a bit of a taste for maths, physics, science, so the STEM side of things. And as I guess, went through my high school career, I just knew I wanted to be in a position in the future where I could build something and create value in the world. So I really, throughout high school, built this kind of picture of what I wanted to do in the future. I wanted to be an innovator. I wanted to be in a role where I could build something, and engineering just fit that title. I mean, I thought of especially going down that kind of academic path, I was thinking law, medicine, engineering, the big three, and engineering is what clicked for me. How about yourself?
Cool. Quite similar to Danish, I chose engineering because I really wanted to create something. In engineering, you get to be creative, to be a problem solver. You get to explore how things work on every day. And another reason that I chose engineering when I was in your position is that because engineering is very broad, so you can be an engineer and work on creating clean energy, and then you can be an engineer and work on detecting cancer. So I believe that engineers are the wizards of our society. They know lots of magic. So people want engineers to solve their problems, and no one is quite sure how engineers came up with the solution. So for me, it was so much fun and so much excitement involved in being an engineer and choosing an engineering career.
Yeah, absolutely. And I really like that point. In an engineering role, you can be a person solving cancer, trying to work on that technology, or you could even be working on robotics. There's such a breadth of work as an engineer, and so many different things you can go into with that skill set.
So Danish, tell us about your role at Cochlear. What do you do as a mechatronic engineer at Cochlear?
So my mechatronics background has driven me into the systems engineering role in Cochlear. So as a systems engineer, I work across products. So I work with the mechanical teams, the electrical teams, the software teams to bring together mechatronic systems. So if anyone's familiar with the cochlear implant system, what we have is an external sound processor. It takes sound in, and then the recipient will have an internal implant that interprets that sound across a link, and then that sound gets sent through to the brain via an electrode that stimulates inside the cochlea. So this device is for people who are either born deaf or lose their hearing throughout life, profound deafness, and it's an incredible space to work in. Being able to change people's lives, being able to give people the gift of hearing is really incredible. Just being able to connect that emotional aspect to the engineering side, using my skills to make a difference, is really why I love my role.
Exactly.
And in that mechatronics role, I get to see the big picture of things. So I get to see how the mechanical elements, the outside, how it actually fits into someone's head, the biocompatibility elements. I get to see the electronic side, so the PCBs, the detailed electronics, and I get to see the software side, so the coding, the implant firmware, the sound processor firmware.
Yeah. And Cochlear is on campus here at Macquarie.
Yeah.
Actually, at Macquarie, there is something unique about studying at Macquarie. Is that, for example, at the School of Engineering, when you study engineering here, we do have a good focus on teaching you the fundamentals and teaching you the theories and the basic concept that you need and the basic skills that you need. But we don't just limit ourselves to the theory. We have one of the best teaching laboratories and facilities here on campus. So right after the student grasp that they require the theory behind the concept, we actually give the students the opportunity to go to the lab. For example, if you have an opportunity to design something as a mechanical engineer, for example, and then in the laboratory you have an opportunity to create, to manufacture that thing that you design already. So our focus here at the School of Engineering is to give you the opportunity to have some practical experience during your degrees here at Macquarie, and then using that experience, that practical experience will be very valuable when you graduated from Macquarie and then you want to go and continue your career in the industry. It's not just about the theory. You had the opportunity of working on the real devices.
Yeah, and talking to Nushin before this about Macquarie University's program, that practical element is so important. Going into my day-to-day work, having that practical background is really essential, and the fact that Macquarie University can offer that with your theoretical study and being able to apply that builds your skills in a very rounded way, and I think that's essential going into industry and any career.
Perfect. So Danish, tell us about what sort of job a mechatronic engineer will have in the future.
Yeah, so I mean, in my role right now, it's a prime example of a mechatronics engineer. So a systems engineer that works with the mechanical, electrical, and software elements, bringing it all together. But mechatronics engineers can also streamline into the individual fields. So I have, especially from my cohort, many mechatronics engineers that have gone into the mechanical side, working on deep projects there, electrical side, software side, obviously research. There's a breadth of engineering through the mechatronics degree. If you do have in mind exactly what you want to go into, especially if it's like a mechanical engineer, then go for your life, pick that role. I think mechatronics is really great if you love to bring it all together and want to get an understanding of all the systems. It is quite a lot to learn, and it can be overwhelming at first, but it is also a great opportunity to learn amazing skills right across the engineering.
Yeah, exactly. So mechanical engineer and mechatronic engineer, they do overlap somehow. As a mechatronic engineer, you get good knowledge about mechanical engineering, and also you need a little bit of electronic engineering and also computer programming. As a mechanical engineer, your focus will be on design and construction and manufacturing of almost every single item that we use in everyday life. And your future as your career, you can work in a very broad section in the industry. You can be a mechanical engineer and work in automotive industry or a railway industry. You can work in the transportation system. You can work in power generation industry, and so it's very broad. You can even work in the insurance industries if you are a mechanical engineer, and this is another thing that I really love about engineering degree.
And that's another good point, that insurance element. So I again know a lot of engineers that have gone into consulting roles that problem solving skill base that you build in an engineering degree is so versatile, it's so robust. I mean, engineers are sought after all around the world for many different roles, and I think by just going down this engineering path, the world is your oyster.
Exactly.
From the mechatronics point of view as well, in terms of jobs, Elon Musk is a perfect example of the kind of person that fits the mechatronics description. Having that complete understanding of a mechanical, electrical, and software system coming together is kind of his jam.
Exactly. So, Danish, if you want to give some advice to people who are listening to you, as someone who already passed this this step, what do you have to tell to them? What do you want them to know can help them to choose a better path, in their career? Yeah,
so I put myself in your shoes right at the start of my university career and say, I guess even I didn't know what path I wanted to go down. I didn't know whether engineering was the right choice. I didn't know what I really wanted to do. Building a story around and building a picture of what you want to do in the future is key. If you can see yourself in a role where for me, it was using engineering to help people. That was the picture I put around it. So being able to create that goal really helps drive that university career, because there's a lot of technical deep courses that you'll go through and you'll learn a lot, but having that big picture view of where you want to be in the future can help you really understand why engineering is such a good choice. And a little bit of bias because I absolutely love it, but being able to help people on a day-to-day basis by building products,
Yeah.
it's incredible.
Yeah,
So I
exactly.
mean, if you can put a story around it and really understand why you're doing that degree, I think that's my best advice.
Yeah, thank you for that. And what I can say to you is that we really need more people to join, to choose engineering as their career. We can do a lot as an engineer, and I truly believe that the society needs more engineering, especially in Australia. Australia, we have a very high demand for qualified engineers, but in the universities, we train relatively few number of engineers compared to similar industrialized nation. So we need more and more people to choose engineering and join us, and especially we need more female engineers. We really encourage you to choose engineering as your degree, because engineers can do so many things, and the society relies on skills and expertise of a qualified engineer.
I might even ask, are there any other tips you'd give and a bit of advice?
I think it's good. I mean, the advice you gave, it was also very good. But I think be brave and choose a STEM field, especially engineering field. Do not be scared of like people talk about. There are lots of math and physics involved. Yes, that's true. But think about the big picture. Think about what sort of skills you're gonna get, and what sort of what you will be capable after you finish your engineering degree, and what about future you're gonna have in terms of you're gonna an opportunity to work in a very broad industry. And I think that's something unique about engineering, which is very, very important.
It's so worth it. I've met very few engineers that have regretted doing an engineering degree.
Yeah, exactly. So I think we can wrap it up here, and we're gonna have. If you have any question, you can ask these questions from our academics and from our student ambassador. So there is an Ask an Expert live chat right at the bottom left of this site. So you can just click on that and ask your questions over there. And then we're gonna be live all day here at Macquarie University. Okay, so the questions are coming here. Thanks for Liam. Liam has asked. That question is from me. So he asked, "What is my current research project?" You're making a mistake, Liam, because if someone asks me about my project, I can keep talking about my project for forever. I love what I'm doing. So my expertise, I'm a nano material expert. So I'm working in nanotechnology. My current project, I'm working on super tiny sensors that they can be manipulated and they can be trained to be sensitive to whatever you want. One example is that I made my team, we made a super tiny sensor that can be embedded into your smartwatch, and that sensor is sensitive to UV light. So imagine that you're wearing that device and you're walking outside, and the sensor can measure how much UV is absorbed by your skin. And we truly believe that this is the very important innovative device which can save lots of lives, especially here in Australia, because Australia and New Zealand, they have the highest mortality rate of melanoma in the world. The thing is that about UV, from one side we need UV because we need the UV to for our body to get vitamin D, but from the other side, too much UV exposure, you're gonna get a risk of developing skin cancer. So such a device, which I have to mention that this device is a multidisciplinary device. So the sensor itself is based on nanotechnology and a little bit of chemistry. And then we had a mechanical engineer who designed the hardware of the device and how we can be comfortable when we're wearing that device. And then we had electronic engineers who were involved in how they can make the device wirelessly communicate with your phone. So when you're walking outside and the amount of UV absorbed by your skin is above the limit, you receive a text message on your phone tells you that this is above the limit, so it's better to get back inside, which is helping us to get some better sun safety, especially in Australia.
And you recently
Yep.
made a radio appearance about that.
Yeah, so we are trying to kind of talk to the society, because at the university we are using the taxpayers' money. So this is our responsibility to get back to the society and at least explain to them that what we are doing and how we are spending that money here at
It's
university.
amazing technology.
Sarah has asked, how does nanotechnology incorporate with mechanical engineering? Nanotechnology is the science of everything. So you can work on nanotechnology and be a mechanical engineer. There are so many things about nanotechnology involved in mechatronic and in electronic, in biology. So nano is the science of scale. So if you can work in such a small scale, no matter if you're a mechanical engineer or a mechatronic engineer,
Electronics with PCB boards.
Exactly, and that's
with
how everything is
microchips,
getting smaller and smaller and smaller. So we have like a very small electronic devices. Is because of that the nanotechnology that has been used to kind of improve the efficiency from one side, and then to also make things smaller and. So we have another question. Akira is asking, what subject would you suggest to take in high school if you want to do a degree in mechanical engineering?
Yeah, I can even answer that from my end. So even if you didn't take these subjects in high school, I think there's no limitation to heading towards an engineering degree. I wouldn't hold yourself back for that. I think they have those standard prerequisites of maths generally, and then anything else is kind of an extra. Physics, again, a supplement, but really I wouldn't restrict yourself from those, as long as you can meet those entry requirements. I mean, the skills, those first year courses teach you exactly what you need. And I can see another question up there, which was about the first year. Was the first year very challenging?
Yeah.
Was it very challenging? And again, those first year courses really set you up. They give you a comfortable space. Everyone's beginning. University and even Macquarie, they really take care of you and just make sure you can build your skills up. So don't feel nervous or worried about that end. You can definitely do it if you're passionate.
There's another question coming. So if is engineering studies a course in high school if you want to do mechatronic engineering?
So again, from my entry, and this was about 6 years ago, the prerequisites for all my engineering disciplines were the same. So it was entry level of maths. I think for equivalent it was 2 unit, maybe 3, and then I had physics, and I did chemistry, and I did kind of those STEM based subjects. But I talk more to the Macquarie University faculty about prerequisites and what you need.
Okay. Yeah. So. Yep. Oh, okay. So another question for you.
Yeah, so I'll take that. So Ben has asked, what products are you working on at Cochlear? That's a really interesting question. So our standard product, and the one that's really developed out in the field, is our traditional cochlear implant system, which has our Nucleus 7, which is the latest behind the ear sound processor. So it sits on the recipient's head and then sends those signals through to the internal implant, which allows the recipient to hear based on the signal received. Currently, we're working on more innovative technologies. There's a lot of innovation products going on at the moment, some which I can talk of, some which I can't. One of the key ones I can talk about is the completely implantable cochlear implant system. So this is taking that external microphone and actually integrating it into the full implant so that it's basically invisible hearing. And that's that's one key product in Cochlear's pipeline. There's plenty going on. There's a lot of cool development up ahead. So
okay,
watch this
perfect.
space.
So there's another question is, how does, so Ali is asking, how does one achieve early entry into engineering at Macquarie Uni, and does the fact that I do engineering school affect anything? Yeah, so this question, I would recommend to ask this question in a live chat. So we do have some academics experts sitting in a live chat that they can give you a very comprehensive answer about the degree here at Macquarie University. Okay, there are another question for you. So Sam asked, how did you get your job at Cochlear?
Yeah, so, and that's a really good question as well. I guess when you get towards the pointy end of your engineering degree, that third, fourth year, that's when the talk of graduate jobs and graduate pathways comes up. I applied to quite a few graduate programs that I was really passionate about, and I was fortunate enough to get an opportunity to attend in my penultimate year, so 1 year before graduating Cochlear's summer student program, where they bring on about 20 summer students, and then we do a 3-month internship at the company. So I got to get good exposure at the company, and then was lucky enough to be picked from that summer student intake to start the next year. So that was the pathway I went through. I think thinking about internships and industry experience during your engineering degree can definitely help boost that potential you have to get a job that you want out in the field and really exceed in your career.
Okay, great. So the next question is mechatronics. So why did you choose mechatronics? Yeah, so you could choose any other discipline, any other major as an engineer. Why mechatronics?
That's a good point, and it's a good question from Magella. So I guess I was at the point where, again, in your shoes, about to pick my degree, wasn't really sure what to do, and I knew just from high school, I knew I loved embedded systems. I knew I loved putting everything together, and I couldn't pick. I really couldn't pick. My brother, he was six years older, so quite a big age difference. He was doing software engineering at the time, and I looked up to him, and I was like, wow, the things you do are so cool. But then also, I saw electrical engineers, and I saw people like your big tech entrepreneurs coming out and building these integrated systems. You had Tesla, these kind of companies that were on the horizon, and I just wanted to do it all. So mechatronics was there. It had the potential to give me the experience, and I don't regret it. So I wanted to build all these skills. I hadn't thought out how it was going to happen, but it worked out for me. And I think challenge yourself, as Nushin said, be brave, and put a story and a vision about where you want to be.
Exactly. Yeah, exactly. So we have another question from Hart is asking, what do you think is the importance of having women in engineering? It's absolutely important. We need both men and women. We need both female and male engineers, because women are half of the population, and we're not gonna lose the opportunity of using the expertise and the different problem solving that these women and men they do have. I strongly believe that we need all these people, not only women and men, but also people from different diverse group of people, from different culture, from different from different discipline. We need all these people to come together when we are tackling a big problem. Is impossible to solve a big problem and offer a reliable solution if you have only a very limited diverse group of people in your team. So the thing is that when you have these different people, like different gender, different culture, different age, different discipline, different skills, the thing is that this is the same problem. Is one clear problem, but people from different gender and different discipline, they look at the same problem from this different perspective, and that's the best way that you can offer a reliable solution to solve these problems. And people are they've been trained differently, and they have different way of thinking. So having women in engineering, women in STEM working together with men, having different diverse group of people together working to tackle a problem, I see that's the only way that we can offer a good, reliable solution to real life problems that the society is facing right now.
Absolutely. And Nushin, I completely agree. That element of perspective is so important. Working in at Cochlear in that product development space, I mean, we don't just design products for men. So we need that perspective. We need
Exactly.
that input. Like, it should be split. You need the diversity to ensure that everybody's point of view has been considered. And if you don't have that diversity in a field, you're really lacking what could be.
Exactly.
And it's essential.
It is
essential.
impossible.
So
it is impossible to get to what we wanted to get without the contribution from these
and
different
it's a gap in the industry at the moment that needs to be fixed.
Exactly.
Yeah.
So we really need you guys to be brave enough and to choose a STEM, especially choose engineering as your future career, and join us and help us to have to empower us. You can empower us. We can actually have a good team here to be able to work together as a diverse and as a qualified engineers to kind of work on a very important problems that the society is facing right now, and that's the only way to tackle these problems. Jennifer is asking one question from you. So how do you incorporate the concept you learned in your degree through your work?
That's a great question, Jennifer. So the concept I learned in my degree, and how do I incorporate that into my work? I see that day to day, I think the foundations that I built from my engineering degree are essential. I mean, you learn all these deep technical skills that you get to explore at a high level in your company. Obviously, you do, especially in a mechatronics degree, I did a wide range of courses. And there are these little elements within the degree that I really loved, and I get to apply today. And there's some elements don't use as much. So you can be very focused, and there are the beauty of a degree is you get exposure to a broad range of concepts, broad range of elements, a broad range of technical abilities, and then you can build those capabilities as you please, based on what you're passionate about, based on what you think will make the most value, change the world, whatever your goals are. You can in the walls of the university, you really have the opportunity to develop these core skills to work them out in work.
Yes. Yep. I think there is another question asked, what made you decide to do an engineering course at Macquarie? I strongly believe that Macquarie is one of the best teaching universities in Australia. So the main focus here at Macquarie is first to focus on teaching, which is very unique about Macquarie. So we do have we value teaching as much as we value research here. So the thing is that people who come to Macquarie for the bachelor and master degree, they can have an opportunity to work to go to the best teaching laboratories here. We have very well equipped teaching laboratories with the best facilities. So as I said, it's not just about learning the concept and the fundamentals about what is engineering. Is not simply about studying math and physics and general concept about engineering. The thing is that after you learn the required skill that you need based on the theory, you will get an opportunity to work on that. For example, the design. If you work on the design and design a machine or an object or a device, then next step is that we can have you to work in the teaching laboratories here at Macquarie and see how you can make your device or the design to become a real manufactured device. So you can actually work on fabricating and you can make it as a real device. So this gives you a very great experience, a practical experience for you as an engineer. When you graduated and you are looking for a job in an industry, you will have this practical experience, which is very valuable, and it's going to be huge. It's going to be a big help for you to do well in the job that you get after you graduate from engineering at Macquarie University.
Yeah, that's really cool. So there's one last question I think here from Eloise, and that's been again Nush.
Yeah.
What units do you teach at Macquarie University as a lecturer?
Yeah, so I teach a second year unit in mechanical engineering. As I said, my background is a materials engineer, so the unit I'm teaching is engineering materials. So as a second year unit, we give you a very good understanding about different types of materials, from metals like steel to light metals like aluminium and titanium, magnesium. Then we give you a very good knowledge about polymers and composite, and then how you can actually choose the right material for the right application, because this is a unique skill that we really need our mechanical engineers to achieve. When you design something, you know the application. The first question is that what material is the most suitable material to be used for that application.
And that skill is essential for engineers at Cochlear as well. Mechanical engineers at Cochlear need to be able to do that.
Exactly. So the thing is that we really want our mechanical engineer in the second year to have a good knowledge about different materials, their properties, you know, their fail, their weakness, their strong. What is the best application that they can use that material for, and then vice versa. If you're working on the application, what is the best material to be used in that application?
Brilliant. I think we're...
So yeah, so thank you so much, Danish, for joining us today. It was really great having you
for having me.
today. For you guys, check out the on-demand videos and the downloadable content on this page, and check out our competition. Head out to our competition page. There are so much fun and prizes over there. Spot the student and see yourself at Macquarie. And this Studio Central is live all day, covering all things here at Macquarie. Check out Studio Central live stream all day. Thank you so much.